Okay, now we're going to do fundamental theorem again this day. Really, this week is going to be all fundamental theorem. So remember, the assignment is in Google Classroom, right? Is this one, right? Fundamental theorem. And we have been doing these problems. Remember, we did yesterday, we did this one already, and yesterday we solved this. We can solve possibly this one, correct? Let's see this one. This is the graph of the function f shown above consists of a semicircle, here is the semicircle, and 3 line segments. Let g be the function given by the integral from negative 3 to x of ft dt. Okay. Again, we have another function defined through the integral of this function in the graph. Okay, remember, we can possibly get these equations and get the piecewise function for this graph right here. But that's not the idea, because takes more time that you compute the area, because the values of this integral are the area under the graph. So this triangle is base times height divided by 2. That's faster than do the analytical thing, the analytical formula, correct? So we have now to find the first question. So it's find, right, g of 0 and g prime of 0. So we have g of x is the integral, let me just write it here at the board, from 0 to x, ft dt, right? And let me just stop sharing. This is what I have to, and I have to do g of 0, no, g of 0. Let me see, fundamental theorem. Yeah, g of 0 and g prime of 0, correct? And g prime of 0. So I have to find these two values. So, well, it's a function, so I have to put the 0 here to evaluate the function, and I have to put the 0 here. So g of 0 is the integral from negative 3 to 0, ft dt, right? Is the first one. And, well, I have to compute. Yeah. So I have to go to here, to the graph, and then I have to find the area between negative 3 and 0. So I have to, this is negative 3, so I have to find the area in this region, correct? So this trapezoid, correct? So that's not a big deal. Everybody knows the way to get this one. It's a trapezoid, or is a rectangle, right? This rectangle plus the top triangle, correct? So it's very simple. So what is the value of the function? Now, something important is from negative 3 to 0, so you don't have to flip anything. The lower number is at the bottom. So how much is the area?
Of the trapezoid or of the rectangle?
And triangle. Remember, is the area under this line. Under this line. So is this triangle right here and that rectangle, correct?
2.
So, es 3 por 1, 3. This is 3 times 1, 3. And this is 3 divided by 2. So it's 4.5. That's correct.
Oh, okay, that triangle.
So this is your value. You see from the graph, that's your value. Okay, now g prime of x is the derivative respect x of the integral from negative 3 to x of ft dt. And this is the fundamental theorem of calculus. The derivative of the integral cancels, and then you get the function of x. So it's f of x. So g prime in 0 is f in 0. So I go to my graph, and I see that f in 0 is 1. That's correct. So it's very simple, correct? F in 0 is 1. So it's what you write on your paper. So what is the fundamental theorem? Right here and right here. Because this is the way to calculate antiderivative. Well, is the area under the curve. So you get this number. And the second fundamental theorem is the derivative of the integral. That is just you cancel these two and put fx. And that's the second fundamental theorem, correct? So that's why I put these problems in fundamental theorem. Questions? Okay, next question. This is find all values of x in the open interval -5 to 4 at which g attains a relative maximum. Justify your answer. Okay. Okay. Now, again, not necessary to get this function. We don't have to get the derivative. Only, again, g of x equals the integral from -3 to x, ft dt. That's my integral. And then I have to remember, right, the definition of a max. Okay. The max, you have a max at x equals x0, for instance, if, right, g prime of x is 0, correct? So a max or undefined, correct? Yeah, or undefined, this is a peak. And the second criteria, remember, because the mean and the max have horizontal tangents, so you need to know what is the second criteria. So first criteria, g prime of x change from positive to negative, correct? So from positive to negative as the change in a max, correct? So, or g double prime of x is negative. So those are the two criteria to identify a max. What is the criteria to identify a mean? Well, the mean at x equals x0 if, right, if this is g prime of x 0 or undefined, right? And first criteria, g prime of x change from negative to positive, correct? Or g double prime in x0 is positive. Check that these two are equivalent. Going from positive to negative, that's meaning increasing, correct? So your function goes up. From positive to negative, you go down, so the second change is negative. So these are equivalent. So let's go to the graph right here. Where, well, obviously, before the graph, let me just, this one, g prime of x is f of x, correcto? So this is the point. F of x, g of x is f of x. So if you want g prime 0, you have to check where the function f is 0. So now we're going to share right here. Okay, where do you have a relative maximum? Okay, I have to check where f is 0. Okay, is 0 here, is 0 here, right? And is 0 also here, right? There is, correct? Now, which one of them fulfills the criteria for the max? -4, +1, or +3?
-4.
-4 for a mean or for a max? Well, for a mean, -4. For a max,
For a min?
we have to find the max, correct?
Oh, okay. Yeah.
For the mean, you go from negative to positive. So this is the mean.
It'd be 3.
In the max, you change from positive to negative, so it's -3. Now, what happened here? It's my extension here. What happened? Yeah, what happened in this point? The f is 0, but keeps positive, doesn't change sign. So it's very simple. F prime, what is the slope of f here? 0. So f prime is 0. So g double prime is 0. So this is an inflection point, correct? That's an inflection point. Now what happened here? In the peaks, the derivative is undefined. So these are going to be also inflection points. The second derivative has to be 0 or undefined. Here, the derivative of f is undefined, undefined, undefined. So here, the concavity is going to change. So these peaks are also inflection points, plus these ones, correct? I'm sorry. Next question. Find the absolute minimum of g on the closed interval -5, 4. Justify your answer. Okay. It's okay. How do you find the absolute minimum? This is mean. I have here something. This is the mean, correct? So let me just put here again the function g of x equals the integral -3x ft dt. This is so g of x has a relative mean at x equals -4. So let me just put it right here. Stop share. So this is a mean in -4. So same as if you have this one, for instance, you have this right here. So suppose the function is something like this. This is, and suppose this is the absolute, the relative mean. This is a mean. But when you have a function defined between a and b, like this, you have to check the ends. Well, this is a max. Obviously, this is not going to be in the game. I need the lowest point of the absolute mean. Abs mean is the lowest, correct? So I have to check this, the end at B and the end at A. In this case, you see that this point is lower than this one, right? So this is the absolute mean, is the lowest point. Obviously, this is a relative max. Yeah, it's a max right here. But this point is higher than this one. So this is the absolute max, correct? So to check for the absolutes, you have to evaluate the function in the absolute mean, right? In this case, I need the absolute mean, so I need to evaluate the function in the relative mean, and then evaluate at the ends. How much is the function? So I have to do this, right? Oh, okay, right? So I have, let me just take this one. So I have to find the absolute mean. Who's the absolute mean? So I have to do g of -4. I have to find g of -5. And I have to do g of +5, correct? Yep. So I have to find the value of the function here. Now, what is this? It's very simple. It's the integral from -3 to -4 of ft dt. This is the integral from -3 to -5 ft dt. Yep. And this is the integral from -3 to +5 ft dt. Now, how can you know these values? Well, from the graph, correct? So let me just go to the graph again, right here. Okay. I need the value of g of -4. That's -4, so right here, correct? So I need the integral from -3 to -4. So I need the area of this triangle. Let me just draw this one. I need the area of this triangle, correct? I need the area of this triangle. So what is the area of that triangle? So it's 1 times 2 divided by
1.
2. Yeah, it's 1. But this is the integral from -3 to -4. So what I have to do? So, okay, this is the integral from -4 to -3 ft dt, correct? So I have to be careful with this. This is -3 to -5. So this is -5 to -3 ft dt, correct? And this is fine. So I have to take the area of the triangle and multiply times -1, correct? So I'll go to my screen again. So this is +1, but because the negative, this is going to be -1. So this is the area, correct? So the g in -4 is this integral. I switch the limits of integration because they are inverted. This is negative the integral. This is the area of the triangle. The area is 1 times -1, -1. Same is going to happen here. I need the integral of the area between -5 and -3. Let me see. -5 and -3. So I need this area. How much is this area? So how much is this?
0.
Well, all this is 0 because this is -1. This is +1. The area is the addition of these two is a 0, correct? Very good, Rangel. 0. Now, what do you think is going to be the area, yeah, of from -3 to +5? Okay, let me see. Let me just right here, delete and delete, right? So is the area of this portion right here, right? Is the area under the circle, right? Right here. And is the area this triangle and this one. So what do you think? Is going to be more than 0, more than -1, pretty much? What do you think?
More than negative, more than 0.
It's going to be more than 0, correct? By sure, this portion is positive. Remember, you calculate that this was 4.5. Then you have these two portions that are more. So this is going to be more than 4.5. And these two are opposite, so they cancel. So this area is more than 4.5. Check that I don't have to do this circle. This is going to take my time. So what I have to locate is the absolute, correct? So this is going to be more than 4.5. So using these results, what is the absolute mean? What is the lowest point?
-4.
In -4, that's correct. So g of x, voy a poner aquí. Abs mean of g of x at x equals -4. There is. No problem. Cos. Now what? Okay.
Oiga, voy a continuar viendo este video más tarde, pero ahorita tengo que hacer una llamada.
No
Que me voy a
problem.
ir.
I continue.
Pero muchas gracias y regreso mañana. Ahora sí hay tiempo.
Take care. See you.
Sí, bye.
Bye. Okay. Well, let's finish this, Arely. Okay. So now I have to do, okay, what is this one? No, this one right here. Delete, 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 delete. Okay. I have to answer the last question. This final values of x on the open interval -5 and 4 at which the graph of g has a point of inflection. So what is your answer?
Wouldn't it be the -3, the 1, the 1 and the 2?
Correct. Because you
There.
have to write the definition, right?
Huh?
You
Yeah.
have to write the definition on your paper.
Yeah.
A function has an inflection point where the second derivative is 0 or undefined, correct?
Mhm.
Then analyzing the graph, the function has f has a horizontal slope because f is g prime, so the slopes of f prime is the second derivative of g of x, yeah? So is 0 right here, is undefined right here, and right here. So you have 4 inflection points. So you see, quiero que veas este problema. You want to see this problem, right?
Mhm.
No complex math, not the integrals we did in the morning, correct? You cannot use a calculator, but you see that this problem is not simple. All this is conceptual. Catch it? Use concepts and geometric equivalence. The integral is the area. So you don't have to integrate analytically any function algebraically. So just compute the areas because it's the same thing. You're going to get the same number if you do the functions. That's it. Okie dokie.
Mhm.
Okay. You want to do one more or we continue tomorrow?
Como usted quiera.
So you want to try more by your own?
Yeah.